A monotone increasing sequence is always increasing from left to right. In the case of a binary sequence, it includes zeros or ones. If the sequence ever goes from 1 back down to 0, it's no longer monotone. For this medium difficulty coding problem, we're asked to find the minimum number of flips it takes to go from a non-monotone increasing sequence to a monotone increasing sequence. In this example, we're given 0, 0, 1, 1, 0, and we can flip that last 0 to become a 1 and form a monotone increasing sequence. As another example, we're given the sequence 0, 1, 0, 1, 1, 0. Here, there's two options. One is we could flip the last two zeros to ones, making it 0, 1, 1, 1, 1, 1. Another option is that we flip the first one to a 0 and the last 0 to a 1, giving us 0, 0, 0, 1, 1, 1. Both of these would give us monotone increasing sequences, and both of them require only two flips. So now, how do we actually find the minimum number of flips it takes to go from a non-monotone increasing sequence to a monotone increasing sequence? And how do we do it with there's so many possibilities of flipping from ones to zeros or 0 to ones, especially if you make the list really long? And then how do you do that quickly? It turns out you can do this in about 6 lines of code based off just one key observation. Given a sequence, we don't actually care which values we flip from 1 to 0 or 0 to 1. We just care about the number of flips in total. And so as we go through the sequence, for every 1 that we might flip to a 0, we in theory could have flipped the next 0 to be a 1. This means that we only need to keep track of the minimum number of 0 or 1 flips required at every step through our sequence. So now we can do this by keeping track of two variables, call them 1 flips and 0 flips, and also the minimum value of those two variables at each step. So now working our way through the sequence 0, 1, 0, 1, 1, 0, when we see that first 0, we have 1 flips will stay at 0, and our 0 flips will increment to 1. The minimum of those two values is 0, which will save back in 0 flips. You can in theory save it in either 1 flips or 0 flips. It doesn't matter. We just want to retain the minimum. The next value in our sequence is 1. So 1 flips increments to 1, 0 flips stays at 0. The minimum of those two values is 0, so we keep that in 0 flips. We then next see a 0, so 1 flips remains at 1, 0 flips increments to 1, and the minimum of 0 flips and 1 flips here is 1, so everything stays the same. We then see another 1, 1 flips increments to 2, 0 flips remains at 1, the minimum there is 1, so we continue. With the next 1 flips increments to 3, 0 flips remains at 1, the minimum there is still 1, so we continue. With this last 0, 1 flips remains at 3, 0 flips increments to 2, so now the minimum of 3 and 2 is 2, and since we're at the end of our sequence, the number of flips that are required to make this a monotone increasing is 2. To code this in Python, we start by instantiating two variables, 0 flips and 1 flips to 1. Then we iterate over our string s for c and s. If c is equal to 1, we increment 1 flips. If not, we increment 0 flips. And then we set 0 flips to the minimum value of 1 flips and 0 flips for each iteration of the for loop. And we finally return 0 flips. And that's it. If you like this video, please subscribe to my channel, like this video, or leave a comment below.